We will discuss here how a valve rotator or Rotocap works. Our focus will be on only 4-stroke marine diesel generator engines. A few things first that one must realize about the super high speed of operation of valve rotator. For sake of our example, let's say our 4-stroke engine of 720 revolutions per minute is operating with exhaust and inlet valves, and we take one such inlet valve to study the operation of a Rotocap. A little bit of calculation will reveal that the time of valve opening is very short, in milliseconds. If one considers the valve opening overlaps before top dead center and after top dead center of the engine piston, it works out to approximately 25 to 30 milliseconds, and that too, only for a one-way stroke of opening from fully closed position to fully open position. You can imagine the extremely short duration within which the mechanism has to work, given the fact that the valve travel is also very small. A very short travel, in a very short time interval. So, what I have done here is for ease of understanding I have exaggerated the valve travel, the Belleville spring washer action, shape change etc. Our Rotocap here looks more axially elongated because I have increased the vertical distances of the arrangement. I will avoid here going into the details of the benefits of a valve rotator, which are available widely across many literatures which you can read. I am also not going to explain the name and terminology of the various components of the Rotocap. You can stop the screen and see yourself, or you can go to the manuals and check. The sole intention of this video is to bring a crystal clear clarity into the operation of the valve rotator. The counterintuitive fact here is that an axial force generates a tangential force in a perpendicular plane around the periphery of the valve Rotocap, which translates to a torque around the valve spindle to rotate it. In general, any force reduces its components to zero when the component angle goes to 90 degrees. It may be noted that there are various kinds of Rotocaps in industry in general. Some rotate the valve only while opening, while others rotate the valve while closing, and yet there are some complicated designs which can rotate the valves both during opening and closing. For our case, we will see that our valves are rotated only while opening. And after you see this video, you should be able to ascertain which way it will rotate, and during which phase of valve opening or closing it will do so, without having seen the rotator in operation, all just by visual inspection of the construction. Instead of straight away jumping into the valve Rotocap, let us first see a demo of a seemingly unrelated jig, a simple jig, where a falling block lands on a freely standing steel ball on a surface. This falling block has an inclined plane at the bottom which encounters the steel ball. We want to see what happens to block itself and the ball on contact. One can note that because of the inclined plane the ball deflects to one side and the block deflects to an opposite side. Also note a very important thing. The ball rolls away instead of sliding away. We will come back to it later why this is so important. Here the axial force is fed by gravity, which by virtue of the slant plane of the falling object, which we call a ramp, impart a sideways motion to the block as well as to the steel ball, but on opposite sides. This is the same principle that occurs within a valve Rotocap. Also note that if the block drops from a larger height, the deflection is also larger. Also, the angle of the ramp matters how fast the two will move away. A steep angle will make smaller movements, a shallower angle, on the other hand, which, although will make it difficult to start the sideways movement, will make larger movements away from each other. Researchers have long worked on optimal movement for reliable long-term use, to shape the ramp accordingly. There are many US patents on this. Some come up with a varying ramp angle, starting with a steep angle to make the movement easy to start with, and then gradually changing the angle of the ramp to a shallower angle once the ball movement starts, such that the starting is easy and then it can travel a greater distance. The valve can thus be rotated at each installment to a higher angle. As you have seen in the example of a falling block, which take assistance of gravity and slant angle of ramp, for a Rotocap we do not have the luxury of using gravity. So instead, a similar axial force on the steel balls to push it against the inclined ramp is provided by an alternate arrangement. This alternate arrangement is the Belleville spring at the bottom of the steel balls which act upwards, from bottom to push up the ball shoe. This Belleville spring acts in two funny ways. Firstly, it works like a clutch plate, which engages the steel balls by pushing up the spring shoe onto the inclined ramp when the valve starts opening with its downward stroke. The second property of this Belleville spring is very unlike a regular clutch plate which engages gradually when pushed to engage. The Belleville spring washer snaps into engagement with the steel balls in a very short time, almost like a crackle, almost like a toggle switch. Remember that the whole opening stroke has got only about 25 to 30 milliseconds to perform all its magic, and that too, within those 25 to 30 milliseconds, Not the full duration can be used by the Belleville spring to engage. At the beginning of the downward stroke of the valve, when the rocker arm starts pushing it open, these Belleville springs does not immediately engage. As the valve spindle keep opening, the force on this Belleville spring washer keep increasing, spring starts deforming and storing energy, until at some intermediately valve open point, within fully closed and opened ends, this spring crackles and changes its position. This is the exact moment a very high pushing force, axially, locks the balls firmly pushed against the inclined trackway. The balls already traveled up, against the small biasing spring pressures within the ramp groove. The Belleville washer will keep the steel balls engaged, till return closing stroke, to the same vertical position. On return of valve closing stroke, the Belleville spring snaps and crackles back to its original position, releasing the clutching engagement on the steel ball. Now the steel balls are free again, though the valve has not yet reached the fully closed position. In this small window of a breather until the valve shuts fully, the small biasing springs push back the steel balls down the ramp to its original position. In the bargain, what the valve body along with the ramp has achieved is a small degree of rotation of the body itself and attached valve cotter, along with the valve spindle, and resetting the steel balls back to their original position, making them ready for the next cycle of opening. This all happened within 25 to 30 milliseconds. Now, how to identify and know? By simply looking at the internal construction of the Rotocap, whether this Rotocap will make the valve rotate during opening or during closing action. Look at the ramp. If the ball climbs up the ramp during opening, it means that the valve will turn during opening stroke. Look at the biasing spring and the ball direction. The ball will compress the biasing spring traveling towards the spring, so the rotor body will rotate in the opposite direction. Nowhere here is a very interesting construction of the ramp by one of the major engine makers. The ramp doesn't look like a one-sided angled ramp. It looks more like as if it has the ramp beginning from both the sides and meeting in the middle, symmetrical from both sides. Question is why it is designed like this. Give your comment below. Next, we discuss what all can go wrong with this Rotocap during operation. Firstly, lack of lubrication will eventually stop the ball from rolling. It will instead start sliding, and sliding on a dry surface of the ramp will eventually bring rubbing marks and uneven wear to the rolling surface. Thus, the ball will eventually stop traveling the full distance or will completely stop traveling and stopping the rotation of the Rotocap altogether. Also, a stuttering sliding movement of the ball along the ramp will impart uneven jerking movement on the biasing springs. This is eventually seen as broken springs on open-up inspection. Next, dirt in lubricating oil will go inside and accumulate, and at certain point of time will stop the movement of these balls or the springs. If the springs are not able to reset the ball back to their end position, the valve will stop rotating. Next, during assembly, if you put the spring and the ball in opposite or in random order, in a direction such that the ball assembled at the higher end of the ramp and the spring at the lower end, this Rotocap will not rotate.